Hi, I'm Colin, and I've been working on this project called Code Search, which is a search engine for code. It's written completely in Rust, and I want to show you a little bit about how it works. So this is my personal instance of Code Search, which is running on my own code base. And so I'll start by just typing a query into the search bar, and you can see I get some suggestions. I'm going to start by searching for this term, SS table reader. And that jumps us into the results page. And you can see the first result here is actually the definition of that struct. So let's click on it. So if I click on that result, it jumps me straight to the line. And this is inside of the code viewer where I can actually see all the code and read it and share links and so on. And then on the left side, we also have a view of the files. So in the same directory. So I've got some other random files. So let's click on this SS table proto file. And here you can see the protobuf definition of some of the data structures that I'm using in this library, key entry, data entry. And if I just take one of these keys, let's say data entry, and right click on it, I can actually search for the usages of this token. So I'm going to search. And you can see that it gives me two results. The first is where we were just looking, the definition of this struct inside the protobuf file. And the second is inside of our SS table library. So let's click on the second result and find a usage of this struct. And so yeah, exactly. Here we're setting up this struct and configuring it, and we're going to use it. So yeah, that's basically how Code Search functionally works. Maybe we can try to find another example of a struct or a function. Here's one, min heap. So this is a data structure that I wrote in another library. So I'm going to right click on it and I'm going to say find definition. And if I click on find definition, it jumps me straight to the definition of this struct. And so yeah, this struct is used all over my code base, but it's able to find the definition and jump me straight to it. So yeah, that's basically how Code Search works. But what makes Code Search so powerful is the fact that it spends a lot of attention on matching and also ranking your search results to make sure that the results that you get are actually going to be useful and the best and most relevant results at the top. And in order to illustrate this, I want to show a few head-to-head examples of why Code Search is actually better than some of the alternatives, like Github Search. And so let's start with an example, which is a little bit of a tricky query. I'm going to start with this one. It's std fs read to string, which if you're familiar with Rust is a really commonly used function. And the tricky thing about this query is that I actually have the colons in here, which are kind of like special characters. And Code Search has no trouble with this. It's able to find plenty of instances of this function being used, std fs read to string, here, all over the place. So it's able to match this pretty tricky query. Let's look at what GitHub does with the same exact query. So I'm running this. Oops, that's not right. If I take the same query over my same exact code base, but just on GitHub, you can see what's happening here is I'm getting some pretty strange results. So what GitHub has done is it's taken my query and split it into three parts: std, fs, and read to string. And it's searched for those three queries independently. Okay, so you can see the results here are kind of strange. It's not finding the exact query I searched for. It's finding std in a lot of the imports. It's finding an example of read to string, but it's not from std fs read to string. And you know, I can keep searching around. Some of these are actually good results. This one's good by kind of coincidence. This one's bad, right? Like this doesn't make any sense. What is this result? I keep scrolling. Some of these, again, maybe make sense. Some don't. Like this one doesn't make sense at all. So GitHub Search is not doing the correct search strategy here, where it's actually unable to search for some of these special characters like colon. And it's instead splitting up the term into three keywords and doing a lower quality type of search. So that's one thing. But I want to point out another aspect of this search result, which is the first result that comes up from GitHub Search is actually a test file. So this is some kind of weird library. I don't know if this library is even used anywhere in my code base. But it's obviously in a directory called tests. So this is a kind of a terrible result. It's just not a super relevant file. This is not the kind of thing you should put at the top. But in contrast, code search actually gives a really relevant result at the top, which is this function load off. Now, this CLI library is actually used in many places throughout my code base. Every time I write a command line interface, I use this load off function and I import this library. So this is an important library. Code search understands that. And because of that, it ranks this higher. It actually understands the relationships between all of your files and uses that to determine which one's the most important and ranks it at the top. So again, not only is code search doing a better job here matching the keywords, it's also doing a better job ranking them. Let's try another example. So here I'm going to search for the term q.proto, which is obviously a file name. And the first result is the file q.proto. And the second result is actually a build file, which references that file name. 2 results. By contrast, Github Search gives a whole bunch of results, a lot of different results. Now, the first one is actually that build file from Code Search's, the second result in Code Search. But you can see when we go down to some of these other matches, it's matching things like just the word proto and just the word q, but not the 2 combined. And that's because, again, GitHub has split this term into 2. It's searching for q and proto independently and not together. And so it's finding a bunch of junk, basically. A lot of these results, most of these results, are completely junk. Now, what's even more striking about this search result is, remember the file name q.proto? GitHub Search doesn't search inside file names. So the actual file q.proto doesn't turn up in any of these search results. It's not even on page 1, and it's not even on page 2. So like, by far, the most relevant thing you would possibly want to look for with this term is simply not shown. So again, it's just GitHub Search not doing a great job, not finding what you're really looking for, and giving you a bunch of junk. But let's look at some other examples where matching is not the problem, and it's more a question of ranking. So in this case, I'm looking for the term record.io, which is a library that I wrote. And you can see in Code Search, the results are, the first result is record.io, the folder containing that library. The second result is the implementation of the library. And the third is a build file. Then beyond that, we have some usages of the library. Let's take a look at the same thing in GitHub Search. So here, we're actually matching things like the insides of a string. Okay, these are strange matches. Here, again, a match inside of a string, a match inside of a string, usages of the library, references to it, but not the library itself. Here's a usage of the library, another usage, and then finally down here near the bottom, we actually have the library implementation. So this is the best search result by far, and it's actually near the bottom. So again, GitHub Search ranking your results basically randomly instead of trying to bring you the one that's most relevant. Okay, let's take a look at another example. So this one is more on the question of matching. I'm searching here in Code Search the term read_to, and you can see it matches things like read to end, read to string, read to string, read to end. Okay, a lot of different ideas. In contrast, GitHub Search actually returns 0 results. Now the reason for that is because GitHub Search uses keyword matching, and it's unable to match inside of a string. So it can't match a prefix, a suffix, or inside of a string. Code Search, by contrast, uses trigram index, which means it can search anywhere inside of a string, and even with special characters. And so that makes GitHub have this weird property where if you even add some more characters to the string, say I add the read to end here, it will suddenly start giving results, which is really a strange behavior. By adding more characters to our search term, making it more specific, we've actually broadened our search results, which is unexpected behavior, which Code Search doesn't do. And I want to emphasize how important this particular case is. When you have to type the whole term, it makes it really hard to find things that you're looking for. For example, if you imagine you have a really long constant name, and you forgot to put the prefix or the suffix of that constant into your search, GitHub will return 0 results. Code Search, by contrast, not only does it have suggestions, so if I search for a constant, let's say I search for a constant like in memory, it will suggest different possible matches, and also it will match even if you just put the prefix or even an internal part of the query. So it's a much more powerful matching algorithm. And then let's look at one final example of ranking. So here I'm searching for the term read_proto, which is a function. It's a function in my database, the database that I wrote. So the first result is actually the database client. So all of the services that connect to this database, they import this client library and they call this read_proto function. So it's the most relevant result that's being used all the time throughout my code base. The second result is the actual implementation of read_proto inside the database. So also a very good result. And then beyond that is usages. Let's take a look at what Github Search gives. And here we can see it's a use. We got some usages, we got some usages, more usages, usage, 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 usage. And near the bottom here, we actually have a good result. Okay, so near the very bottom of the search results, we actually have the most relevant one. All the other ones are usages. So now this matters maybe not so much if you're searching a small code base like my personal code base, but if you're searching a big one, this could mean that the function definition you're looking for is on page 10. And the actual function you're looking for, you have to scroll through 10 pages to find. And that's incredibly frustrating. And that's kind of an annoying experience. And it's just something that Code Search does way better. And so, yeah, that's kind of a demonstration of how Code Search works. And so you might be saying, okay, this is kind of cheating. Code Search is obviously optimized and tuned for your repository, your personal code base. And that's how it knows how, where the functions are defined and how to look up the imports and resolve them and so on. And that's actually not true. Code Search doesn't know how to build my code. And that's really important because if you have to explain to your search system how to build the code, it can be really, really complicated to configure. I actually run Code Search on my works code base, which is about 2 million lines. And in order to describe how to resolve imports or function definitions in that code base, it would be super complicated. It would rely on Jenkins files, make files, environment variables. We have an internal repository for libraries, which we have to understand. So it would be super, super hard to explain how to resolve imports, function definitions, and all these types of things in a complicated code base. So what Code Search does is it uses heuristics only. So it just tries to guess, based on its knowledge of the language, based on its knowledge of the code base, what are some plausible relationships between different files, and it just tries to use heuristics and guess. And it's not always correct. It's mostly correct. Sometimes it's wrong. It thinks there's a relationship between two files, let's say an import relationship which doesn't actually exist. But it's not really that bad. If it's slightly wrong, the consequence is slightly wrong search results. But for the most part, it's pretty accurate. And it's good enough to make the search much, much more accurate than essentially the random rankings that you get with GitHub or maybe your IDE or whatever. So yeah, that's Code Search. I want to show one more thing, which is a terminal UI for Code Search. So obviously, you want to use Code Search when you're looking for code, reading code on the internet. You want to share URLs with your colleagues and so on. But you also, ultimately, you're going to want to edit that code. And so you want to have access to the power of Code Search inside your editor. I run Vim. So I wrote a terminal UI that connects to Code Search and issues its queries. And I can give you an example of how that would work. So I'm inside of my Vim right now, and I'm going to use a hotkey to pull up the terminal UI. And I can just search for something like, let's say, look for a term compaction. And that's a function inside of my database. So let's take a look at that. And it pulls up some functions inside of the compaction library in my database. And then let's say that I want to find the definition. We've got the struct here called compaction policy. Let's say I want to look up the definition of that struct. I've got a hotkey for that too. So it'll just say def compaction policy, and it pulls up the protobuf where that struct is defined. I pull it up, and there it is right there at the top. Again, just something to help integrate Code Search into your workflow. So yeah, Code Search is really easy to try. If you want to try it, you can do so either on GitHub. You can check out the README, or you could do it on Code Search itself. There's a one-liner to run Code Search in a Docker environment. It'll try to index your code, and it'll run an instance. If you have any feedback or you give it a shot, let me know. I'd love to hear from you and get some feedback and try to make it better. Thanks for watching.